All right, my name is Tim Stewart. I'm here today to talk about the bottom line impacts of Industry 4.0. And, um, you know, at Visual Decisions, we've been working with Industry 4.0 solutions for a number of years now and have seen the tremendous impact it can have on our customers' bottom line. From a functional or operational metric point of view, we've seen scrap reductions of 50%. We've seen OEE or throughput increases of up to 30% and so forth. And so how that actually translates to the bottom line financial impact is the main point of what we'll talk about today. First, just briefly, what do I mean when I talk about Industry 4.0? If we look at the graphic from the World Economic Forum here, we can see that there are a tremendous number of different technologies that are part of Industry 4.0. I listed kind of a subset of them over to the left, and the ones that I primarily focus on, that Visual Decisions primarily focuses on, are the ones that are highlighted in the blue box there, with advanced analytics and IIoT and machine learning and AI and augmented reality. And so, these software solutions that you can utilize to collect data from the shop floor, to analyze that, and to really help direct your improvement process. So with that, I do want to say that the technologies alone are not enough. I use the example of a Fitbit all the time, where I've been wearing a Fitbit for over 8 years now, and I've gained 20 pounds during that time. The Fitbit itself is a great example of an IoT device. It collects data from my wrist and passes that information up to the cloud. It has machine learning things there that can take that raw data from those sensors and turn that into footsteps and heartbeats and everything else, and present that information in nice, pretty graphical methods and so forth. So why haven't I lost the weight? Well, it's because I haven't changed my behaviors. And so it's the same thing on the shop floor. You actually have to do something different tomorrow than you do today in order to get the value that you're hoping for from these solutions. And so, as you go through this, you have to keep in mind that it's not just a matter of implementing technology and magically everything will get better. You actually have to combine that smart factory with a lean factory or some other continuous improvement methodology in order to reap those benefits. And so when we're interacting with our customers, what we do is we initially map out, what is that vision? What is it that we're trying to achieve? And all of that starts with what is the value that we're hoping to get from the solution. And based on how we think that we can achieve that value, what are the root causes for the current performance, and how can we address those to mitigate or eliminate the different losses? And what we want to do is we want to utilize any existing capabilities that you have on the shop floor to collect that data automatically and utilize that within the improvement process, but then also work with you to identify, what are the best ways to fill those capability gaps, and utilize some of these advanced solutions in order to really supercharge what can be done with that information from the shop floor. And then also just looking across the different processes. The example I use here all the time is warranty, where taking the warranty information from the field and analyzing that on its own is interesting, and provides opportunities for companies to identify ways that they can improve. But if you can take that back into the manufacturing shop floor and see what happened during production for those items that ended up in warranty versus the ones that didn't, that can be extremely illuminating in terms of how you can avoid those warranty costs in the future. But again, throughout this whole process, what we're doing is we're looking at, how do we need to transform the culture and the process in order to really take advantage of those solutions that we're putting in place. So with all of that said, what are the actual impacts to the operational and financial performance? So if we look at the potential value that the World Economic Forum lists out for good deployments of these different technologies, you can see from a productivity point of view, significant increases in factory output. And presumably, if you can, if you're in a place where if you can make more, you can sell more, then obviously that's going to be very good for you. Quality cost reduction, product cost reductions, OEE increases. From a time to market perspective and speed and agility, being able to reduce that time to market, reduce the inventory and the lead time. Looking at lot size reductions, changeover shortening, and so forth. And then from a sustainability point of view, being able to reduce the waste and have significant increases in energy efficiency. So all of those are potential values coming from an authority such as the World Economic Forum. And then another authority in the marketplace, McKinsey, back in 2017, put this graphic out there, looking at a lot of the different levers that you have with these solutions within the Industry 4.0 suite. Looking at time to market reduction, maintenance costs, productivity increases, downtime reductions, et cetera, all being capable things that you can get done with Industry 4.0. So how do we actually go about achieving these things? Well, the first way is that if you look at an overall metric like OEE, overall equipment effectiveness, best in class for, and this is highly variable based on the industry that you're in and the type of equipment that you have in place, but typical best in class in different industries is around 85%. And the average utilization across many different companies is around 40 or 60%. So if you can, increase that effectiveness by reducing your losses, then obviously there are a lot of different capabilities to recoup financial benefits from that increase in efficiency. And by the way, how we go about going from a 40 or 60% to an 85% is exactly the subject of next week's webinar, where I look at reducing your OEE losses. So with this increase in efficiencies, how do we go about actually monetizing that? Well, one way, as I said, is if you're in a position where if you could make more, you could sell more, then when you increase that efficiency, the obvious thing is build more parts and build more units and get more out the door, and you'll increase your revenues, and whatever your gross margin is, you should be able to add that much to your bottom line. From an operating cost perspective, if you aren't in the situation where if you make more, you can sell more, then you can work less hours, you can buy less materials, et cetera. And assuming that you have quality reductions and you can reduce that waste, I'll get into the details in a minute. But assuming that you can increase that efficiency, then you could work less hours and reduce your operating costs. Another benefit that you could achieve is if you can take that net gain in time and do more changeovers and cycle through the different products more rapidly, then you can carry less inventory, reduce your lead time from manufacturing for different products and so forth, and have essentially a higher margin for your operation. So these are some different ways that you can spend that excess capacity, and I'll get into more as I go through how you actually tie all of this into your financial performance. So when we look at what those impacts to financial performance are, What I like to do is to start from, the income statement or the P&L and look at, what are the impacts on revenues? What are the impacts on expenses? From a balance sheet perspective, how can I impact inventory and how can I impact my investments in PPE? And so, from there, if we look at revenues themselves, how is it that we're going to increase revenues? Well, the really obvious answer is the one that I've hit on a couple of times already, which is if I could make more, I could sell more, I increase my efficiencies and therefore my revenues go up. But there are other levers that I have in terms of being able to, increase those revenues as well. So for instance, if I'm selling B2B and, I currently have a relatively poor on-time performance, then if I am able to increase that on-time performance, I will be in better standing with my customers and they might order more from me. I can also, avoid cost pressures from my customers. If I'm costing them money by, being late on my deliveries, then if I can avoid that, then I can perhaps charge a little bit more for my products because I'm, now a much more reliable supplier. Speaking of being a more reliable supplier, from a quality perspective, certainly, if I can improve the quality and the perception of my quality in the marketplace, from a B2B perspective, I'm not going to get chargebacks from my customers. I'm not going to have returns and so forth. But then I will also have the ability to, charge a higher price for my product if I have a higher quality product, and increase revenues on the same number of units. But then also, I might open additional opportunities for sales. And any salesperson would tell you that it's easier to sell a higher quality product. And so if you're in a B2C type of marketplace, getting that reputation for higher quality within the market is certainly going to make it easier from a sales and marketing perspective to gain that additional market share and so forth. And then also from a new product introduction point of view, if I can decrease the ramp up time, getting new products, up to speed within manufacturing so that I can, make them more effectively, more quickly. And I can, just increase that new product introduction time by sharing information from manufacturing back to product development and from product development out to manufacturing more effectively. And, run a design for Six Sigma, design for manufacturing process that, effectively ties, those processes together so that I can get those new products to the market more quickly. Then that's certainly going to help me, capture additional market share and increase my revenues as well. So there are quite a few different drivers for how we can increase revenues beyond simply just increasing OEE. And if I can make more, I could sell more. From a material cost perspective, again, the obvious one here is quality loss. If I have to make 110 pieces to get 100 good ones, then I have to buy 110 pieces worth of material, raw material in order to make those units. If I can only need 100 to make 100 good pieces, then that's 10 less pieces worth of raw material that I have to buy. Overages for many industries, such as food and beverage, where you're filling a 12-ounce container and you have to have 12 ounces, in that container every single time. Usually, what you're going to do is you're going to have some level of variation on that fill, and so you are looking at, setting your mean to 12.5 ounces or something like that, so that you can guarantee that you have 12 ounces in pretty much every single container. And if you can, tighten up the variance within that process, within that fill, then you can have, less overage and basically give less product away for free. From a vendor quality perspective, A lot of times, other than just doing a basic inbound inspection, there's not a lot of traceability that you have within your manufacturing process. And so where you discover issues with the raw materials or with the subassemblies that you're bringing in from the vendor, if you don't have that lot traceability, it's hard to go back to the vendor and say, you caused issues, in production on these days, these were what the problems were, and so forth. And utilize that both from the point of view of working with that vendor to improve that product quality, but then also being able to utilize that in negotiations for looking at cost down and things like that, so that you can actually take the cost that you have in manufacturing from those bad parts and so forth, and pass that back to that vendor that is costing you those things within your manufacturing process. And then, from a warranty perspective, if I have replacement parts that I'm shipping out to customers and so forth based on warranty issues, usually I'm sending those out for free. And not only do I, have the cost of that part, but I also have the shipping costs and so forth. And so any of those replacement costs, replacement parts that I'm either adding manually within my own warranty, repair operation, or sending out to customers, those are all things that are just bottom line impacts of material cost and additional labor costs and transportation costs that I'm incurring because I didn't have the proper quality process in the first place. From a direct labor cost perspective, the first impact here that I'm going to highlight is overtime. Certainly, if I can reduce the variability within my manufacturing process, I can reduce the amount of overtime that I have to run. Very often, I'm running overtime because I had a quality issue or because I had downtime, within a process. And because of that variability within my manufacturing process, I have to pay people to work overtime to kind of make up the difference there. But then also, I may have structural overtime at various points of the year where, because my capacity is limited, I just have more demand than I can make at that time. Well, if I increase my manufacturing efficiencies and so forth, that raises that bar of how much I can make during regular hours, and I will have to run less overtime as well. If from a building extra material perspective, I'm going to hit this one a lot. If I'm making 110 pieces to get 100 good pieces out, then that takes more time to actually make those extra parts, and so I have a direct labor cost that's associated with that. If I have issues within my manufacturing process and I have that variability, inevitably, I end up paying operators to stand there next to an idle machine and wait for the parts to arrive that they need to process. So anytime that I'm seeing that, idle time on the machines, typically I've got, operators that are going to be there idle as well. And, downtime, if I can reduce the downtime, that is also time that I'm basically paying that operator to do nothing. And so if I can reduce my downtime, if I can reduce the time that they spend waiting for parts to come from upstream, or if they're blocked from going downstream and so forth, then I don't have to pay that operator to do nothing anymore. From an inline rework perspective, if I have quality issues and I'm paying that operator not only to build the part in the first place, but to fix whatever quality problems happened on it, they're at the station, then again, that's a direct labor, cost that I can avoid. And then if I have, inline testing and inspection and so forth that I have to have as part of my process because I have that variability within my process, if I can eliminate the sources of variability, then I can eliminate a lot of that inline testing and inspection requirements as well. So lots of different ways that I can impact that direct labor cost, in addition to just the efficiency as well. From an outsourcing perspective, so if you're outsourcing because of capacity reasons, then if we can reduce the amount of downtime that we have, if we can increase the efficiencies within our own facility, then I don't have to send material out to somebody else to build from a capacity perspective anymore. And a lot of the ways that I do that, I reduce my downtime. I do faster changeovers and setups so that I don't have as much issues there. I can identify and eliminate waste more effectively. I can run faster production rates, et cetera. Then those are all things that are going to help me increase my efficiencies within my own facility and help prevent me from having to outsource manufacturing due to those capacity reasons. Indirect labor. So if I look at different shop personnel, if I have testing and inspection, and I have various people that are doing nothing but testing and inspection, or even part of their job is testing and inspection. Again, if I can produce quality parts on a reliable basis in the first place, I can reduce how much I'm spending on that testing and reduce the amount of inspections that I have to do and so forth, because I know that I'm making good parts in the first place. From a rework perspective, if I have rework stations that I'm manning and so forth, if I have entire non-conforming material process in place and various people staffing that, then if I can improve my quality, I can certainly reduce the amount of labor that I'm putting into those activities. From a maintenance perspective, obviously, if I can keep my machines up and running more effectively, there's less downtime. I need to have fewer people that are in place in order to respond to that, reactive maintenance perspective. And this, also, impacts things from a preventive maintenance perspective. If I can shift from, doing things every, 10,000 pieces or every, X number of hours, then I can optimize that process and reduce the amount of preventive or maintenance I have to do and shift that over to predictive or condition-based maintenance. And hopefully reduce the overall maintenance that I'm performing as a result. Engineering support and quality support and continuous improvement support and so forth. Again, if my process is running effectively and I have fewer issues with it and so forth, then I may not need as much on-site support as I would if I have a lot of problems and people are continually fighting fires and so forth. Or these people can utilize their time more effectively and make everything more efficient and have a lot of those other benefits that we've talked about so far. Also, from a corporate perspective and indirect labor costs, I have product design up here first, but even though you have an engineering impact, if I'm able to share information from the shop floor and from product out in the field where I'm getting telematics data back and being able to share that with engineering so that they can do their jobs more effectively, I can either increase the number of products that I'm making because I have a more effective process, or I can reduce headcount in those areas and still produce the same number of new products. But from a more direct perspective, the amount of people that I have to have in my customer service, call center, warranty repairs, field service labor, and so forth, can be directly impacted by increases in quality within my process. If I have fewer problems out in the field, then I need fewer of those people to deal with those problems out in the field. And then, just from a sales and marketing perspective, hey, if I'm making better parts and I'm shipping them on time, I don't have to push as hard in the market. I can get more pull from the market because I have such a sterling reputation out there. From an indirect materials cost, manufacturing consumables, I'm working with various customers on solving the tooling dilemma, where if you leave a tool on the machine too long, you start producing bad parts. But if you take it off too soon, then I'm spending more on refurbishment and replacement of those parts than I actually have to. And how do I optimize my maintenance spares? How do I have enough information coming from the process to let me know, which parts are approaching their end of life, so that I can order them more on a just-in-time basis, as opposed to continually keeping those maintenance spares, because I have no idea when they're going to fail and so forth. And so everything that I can do in these areas around those manufacturing consumables, the tooling, fixtures, dies, molds, etc., as well as the machine parts and everything else, the more information I have, the more I'm able to predict those things as opposed to reacting to them, the better job I'm going to be able to do in reducing the amount of inventory that I have to carry for all of these things. Not to mention the fact that if the machine breaks down less, I'm going to probably utilize fewer spare parts as a whole. From a logistics cost perspective, I don't know how much your company spends on expediting today, but if your manufacturing process ran with less variability, I guarantee you would spend less. So certainly expediting fees are huge target for being able to look at the impact of Industry 4.0 on cost reduction. But then material purchasing itself and paying for logistics of inbound materials, outbound, etc. Those are all things that, again, if I only have to make 100 instead of 110 to get 100 good pieces, then spending less on the logistics associated with all of that. From a scrap removal point of view, those 10 bad pieces, they have to be dealt with somehow. And so, I'm paying money to remove those pieces of scrap from my environment as well. And then, from a reverse logistics point of view, for warranty expenses, I'm paying to have the customer ship those materials back in, then I'm paying to, get the part back out to the customer, or I'm paying for the shipping fee to replace that at the customer site and so forth, as well as the part that's involved with that. And so, there are logistics costs that I can avoid from a warranty perspective as well. From a maintenance cost perspective, this is more the maintenance labor, the tooling, everything else. All of those costs can be impacted by this. Then also from a utilities perspective, if I'm making 110 pieces to get 100 good ones, I'm paying 10% more on the electricity, gas, water, oils, everything else that I have to, because of the fact that I'm making more pieces to get the ones that I want. If I can monitor my usage, I've talked to customers that have vampire usage of electricity, because the machines don't get shut off during off shifts, and they have no visibility of that unless somebody literally walks around to every single machine to make sure that they're off. But if you have a meter on the machine, you can immediately see whether that's still drawing power during off shifts, and have somebody shut that down, as long as there's no startup cost associated with that. But you can actually do that trade-off with actual data for what is that startup costing you in the morning versus what am I saving? How much is that machine actually consuming from a utility cost perspective by leaving it on overnight and so forth. And so those trade-offs I can make either intelligently, or I can just know that, hey, all I have to do is turn the machine back on in the morning, it's ready to go. Then I need to have that turned off at nighttime. So shifting over to the balance sheet perspective on all of this, we've talked about being able to do shorter changeovers. If I can, inform my SMED process with better data and, more effectively reduce my changeover time. If I can, have the work instructions, for the optimal changeover time or optimal changeover procedure, given to all of the different employees that run that process. and reduce the amount of variability that I have in that changeover time, then I can run those changeovers much more effectively. If I can do that, and if I can build with smaller lots, that helps me reduce my finished goods inventory, because now the amount of time that it takes me to cycle from part A to part B to part C to part D, et cetera, and then back to part A before I ship that out to finished goods becomes reduced. And therefore, I can reduce the amount of finished goods inventory that I need to carry. If I can reduce the lead time on the shop floor, if I can reduce waste, if I can identify where I have non-value add activities happening so that I can eliminate those, and all of those things are going to help me reduce the work in process inventory that I have out on the shop floor. If my manufacturing process becomes more reliable and I have less variability, and I'm not having to suddenly make part A because the machine that I need to make part B broke down, and so I had to make something else, and so I'm making A's now. So I've got to carry inventory of raw materials to make A's, even though I know I'm making B's, because I just don't know. I've got that just in case factor on my raw material inventory so that I can keep my factory running in the face of uncertainty. If I have less uncertainty, then I don't need nearly as much just in case inventory. And so I can reduce that as well. So certainly from an inventory perspective, there are a myriad of different ways that I can impact how much material I actually need. And then from a balance sheet perspective, obviously, if I make my equipment more effective, I don't, and I want to increase my capacity. If I can get more out of the machines that I have now, I can avoid spending on new machines to increase that capacity. I've worked with customers that avoided, had in their capital budget an entire plant that they were able to avoid because the existing facilities were able to increase their capacity by enough that they didn't need to build that new plant. But also just from the point of view of rework equipment, testing equipment, and so forth, if you can build good parts in the first place, then you don't need as much equipment to rework them and test them and everything else. And so you can reduce that cost as well. Very quickly, from a visual decisions perspective, we have a very well-defined process that we go through with customers to identify, what potential value is there, in that manufacturing process with these Industry 4.0 solutions. And we start with, from a functional perspective, what are those high-level objectives? Is it to increase throughput? Is it to reduce costs? Is it to improve quality and so forth? And we work through what are the impediments to that performance, getting down to a causal level that is something that can be addressed. And once we get it down to that level, then we start to work to identify what are the enablers that are out there with Industry 4.0 that can directly impact those causal factors. And we look at what are the processes that you have to adjust within your manufacturing environment to take advantage of those new enablers, to provide capabilities within the business that are going to run that process more effectively. And then we can estimate what are the potential benefits and potential outcomes from that process. And so we go through a discovery process with our customers to identify what are those different opportunities, what are the different inputs that are required in order to estimate the value for those different items, and then go through that causal analysis to identify what are the things that we have to address. A quick example of this is with OEE, we've identified a whole set of different functional and financial inputs that are required in order to estimate that potential value from OEE, and I've run through a lot of those things here today. And then from a causal factor perspective, one easy way to do this is just to look at the typical big six losses for OEE, with unplanned stops, changeover, short stops, reduced speed, production scrap, setup scrap. And then what are the capabilities that we could put in place that help address those? And we look not only at how much impact we think that capability is going to be able to have on unplanned stops, but what is the timeline that we expect that to happen across. And we do that by going through this mapping process of how long we think, or how much of an impact we think those different factors has on our current OEE. What are the losses that we're seeing based on those different factors? And then going through and identifying for each of the different enablers that are out there, how much of an impact do we think it's going to have? What's our timeline? What level of impact do we think we're going to have? What is our success? What's our confidence in our success within those different areas and so forth? And from that math now, we can identify how much value we think we can achieve across different financial areas, as discussed during the presentation here. And we can see how those will ramp up over time. For each of the different enablers, we can say, from a project planning perspective, what are those things that we think can get us a big impact, but also do it quickly so that we can put those at the beginning of the project and have a project that will basically pay for itself over time. And then, having a full project display with different solutions, different dependencies between those. What are the improvement levers? What are the process changes that we have to put in place to really take advantage of those things? And then go through and identify what are the different relationships between the different enablers. How are they tying to that dollar impact? And what is the relationship between each one of those different elements? So very detailed process that we can run through with our customers. It doesn't take a long time, but it does get us some very good answers. With that, I want to thank you for attending today. Here's how you can contact me. Please reach out if you do have questions. I do see one question in the Q&A, which is, once you help a manufacturer identify the opportunities and enablers, do you have solution providers and partners that you can engage? And absolutely, I work with a variety of different companies that provide these solutions and can work with you to identify which one of those is going to be the best fit for the different issues that you have within your operation and the different factors that you have that are impeding your current performance. So with that, thank you very much for your time. I will have this available on my website, the recording, in case you want to share it with anybody. And if you want a copy of the presentation, you can either reach out to me directly, or I'll have a copy of that downloadable from the website as well. So thank you very much. And I look forward to next week when we talk about how we actually address those OEE losses and inefficiencies within the plant. Bye.